Luck.
Hello, everyone, and welcome to the considerations when finishing printed multi-jet fusion orthotics and prosthetics. I am just going to pause here just for 30 seconds or so as people join on our webinar. We will get started promptly though, because we have a lot of great content to review and go through today. We're quite excited. We've been working pretty hard on this for quite a while now, so we're excited to show off what we've been working on. So why don't we go ahead and get started and jump forward here. Great. So I know people will be joining in, but that'll be okay. There's a little bit of a buffer built into here. So before we begin, I think it's really important to put in context what we're trying to accomplish here. With orthotics and prosthetics, we've been investing heavily in a lot of different ways on how to basically take it to the next level of innovation. And if you've been attending some of our other webinars, you're probably familiar with some of this content, but I think it's important to emphasize that, you know, with orthotics today, for example, you might be used to seeing some of these different types of devices. And what we're really trying to accomplish is to move it up to the next level and be able to bring that blacksmithing type creativity back into the work of what you're doing, and being able to take the designs that you might have in your head and incorporate it into the parts that you are actually producing. Same thing for prosthetic devices. You might be used to seeing devices that look like this today, and we're really, again, trying to push that level of innovation and creativity and being able to build it into your work in ways that might not be possible today due to the way you manufacture parts. And ultimately, though, I think it's important to emphasize that what we're really after here is creating that amazing patient experience, because of course, if you don't have that, nothing else really matters. And we want to be able to produce parts and devices that, you know, allows people to go on living their lives rather than trying to plan their lives around whatever device that they actually have. So it's really important to know that that's what we're after here. And what we've been going through these different webinars is different pieces of the puzzle of how to get to this status. So if this is your first webinar, we'll just quickly review our multi-jet fusion printing workflow. And specifically for orthotics and prosthetics, we're acquiring data via scanning. Then there's some file manipulation that we have to go through. We'll prepare the machine for printing. We'll actually print parts. Then there's some cooling of the parts and post-process of the machine. We'll wind up cleaning some of the parts off. And then optionally, there is a secondary process that you could do, which is really where we're going to be focusing today. So if you've been watching our webinars, we've already been going through scanning, and we went through a file preparation workflow. So if you haven't attended those and you're interested, make sure to check those out. But today we're really going to be focusing on the latter half of this actual 3D printing workflow. So with that in mind, these are some of the topics that we're going to be covering today. So with finishing, there's a lot that you can look at and think about. And I'm sure many of you are already finishing experts and you're used to a lot of this stuff. So we hope to be able to show how and where this might be different from what you're doing today. Now, if you've never worked with 3D printing or 3D printed parts before, some natural questions that might come to mind is, how do you actually post-process 3D printed parts? Is it possible? How can you add personalization into what you're doing? And maybe you might even say, well, what's even considered a quality part? How do you know? And then a question that comes up quite often is, can you actually make adjustments to these parts after you've printed them? How do you actually do that? On top of that, we'll be looking at some high-level design considerations. Now, normally this is something you think about beforehand, but you can also think about it afterward so that you can integrate it into your process the next time around. So we will go through some, how to integrate auxiliary hardware. What happens if you have a big part that's bigger than the printer? What do you do? And then how do you figure out what material to print with? And what's some framework to evaluate that? And then at the end, more importantly, I think, is to hear from experts who are already doing this today. So today we have Jason from Empire Group and Carl from DI Labs. They've both been printing parts for a while and also post-processing parts. So we're pretty excited to hear about what they have to say based on their experience today. Great. So before we jump forward, I think it's also important to show how and where our process lines up with what you might be doing today. So today you probably have some evaluation, diagnostic, and prescription phase. If it makes sense, you might plaster or make an impression. Then you would submit an order. From there, you would create a prototype, fabricate a final part, and then you might go through a kind of a circular phase where you might ship the parts, fit it to the patient, make some adjustments, and potentially make another part if required and actually use it. Now, our workflow follows that same process, but you're going to use different tools during that workflow, specifically at the plaster impression phase, the create a prototype, and final product phase. Now, we've done some webinars already. One of them doing scanning, which is where it's a little bit different than making a plaster and impression. We've also done a webinar already, as we mentioned, on software, which is where it's kind of different for creating a prototype. And specifically today, as we mentioned, we're going to be focusing on this final part of fabricating the final product itself. Now, you're probably using some or a lot of the tools that we're going to be talking about today, but there might be some tools that you're not familiar with. And so we're going to go through an overview of all those different things in that phase. And some of those things that we're going to be reviewing are the cleaning of parts, what kind of equipment that you would use, how much does it cost, how much time does it take. We'll be looking at quality control. We'll be looking at optional post-processing equipment, things that you can consider, and of course, design considerations. Now, keep in mind, there are many, many options out there, and we don't frankly have the time to go through all of them. So this isn't meant to be any type of recommendation for what you should or shouldn't do, but more so to give you an idea of what it would actually take if you decide to move forward with something like this, or work with maybe a service bureau or a parts provider that could actually print these. You're done 3D printing parts. And once you've printed parts, there is a cleaning phase. And if you're not familiar with that, it will vary by technology. Specifically for our technology, it is it has a specific workflow using what we call a build unit. And as we advance forward here, we're going to show a quick video here. It doesn't have audio, but this is what the parts look like once you're done printing. Now, it may be a little bit choppy for you on your side, depending on your internet connection. But once you are done printing parts, you have a build unit with powder, and you have a hose, as you can see on the right side. And that is going to suck up any of the powder that hasn't turned to parts and put it back into our 3D printing system to be used again in a future build. On top of that, the point of this phase is to take off the bulk amount of powder that's around the part or inside of the part, so that it can be reclaimed and recaptured. You're not meant to take all the powder off, because we're going to do that during a secondary phase. So in the secondary phase, now this is using a slightly different part from one of our color printers, but we take it into a bead blasting cabinet. And you can either use a manual bead blasting cabinet like we're showing here, or there's a semi-automated solution, which we'll show in a minute. But you take some glass bead media and you hit the part. And mainly the reason for that is when you're printing in layers, the very last layer, some of the particulates will be partially fused. Maybe half of a particle is fused and the other half is not. So by taking a physical abrasive like a glass bead, it's either going to impact that particle or chip it off completely so that you get a consistent and smooth surface finish. And then the last step, which again is optional, but just take an air hose and dust off any remaining powder. And obviously, if you have some kind of reclaim to capture that powder so that it's filtered and not going anywhere. But you can see that you have a nice, smooth, consistent looking part. And at this point, it's ready to go. Wonderful. So as far as the different pieces of equipment that's out there that you can use this, so as I mentioned, there are manual bead blasters that you can get for this, and they can range in price anywhere from about $3,000 to about $10,000. And as you saw, it doesn't take that long to actually bead blast parts. Depending on the geometry, it could take anywhere from 30 seconds to maybe 5 minutes if you have a really intricate looking part. Or optionally, you can get a semi-automated bead blaster, and that's where it actually has kind of a net, we'll say, to put the parts into, and it will rotate and actually do that process for you. It takes a little bit longer, but because you're doing multiple parts in there, you get higher throughput. And those types of solutions tend to cost anywhere from, say, $8,000 to $30,000, depending on how robust they actually are. Great. Now, moving forward, I'm going to hand this off to my colleague, Wes Kramer, and he's going to tell you a little bit more about secondary optional post-processing. Wes?
Thank you so much, Dustin. So basically everything Dustin just went over up until this point is pretty much a mandatory process as part of our 3D printing process. Everything that we're going to cover after this is an optional step to really elevate the quality of your parts and take them to the next level. So let's get right into it. So here you can see on the left, you have your part right when they're taken out of the printer versus when they're cleaned off. And as I was saying before, this is going to be required regardless of the type of finish you're going for. And what you're going to be left with is a gray part if it's from our production machines. We can print white or full color parts as well in some of our other machines. But you're going to be left with this gray part that kind of has a little bit of this underlying gritty texture from that powder-based fusion that's going on as part of our technology. And what we're going to talk about now is different things to really elevate that. So you can see we have a few different categories that we've kind of decided to focus on for this part of the webinar, including color uniformity, coloring, surface quality, and we're really going to break it down for you and show you how you can achieve this finish beyond what is coming straight out of the printer. So the first thing we're going to look at here is how to achieve color uniformity on the parts beyond straight out of the printer, and we're going to look mostly at dyeing and graphite blasting as the means to do this. So here we have a raw MJF part, a close-up view of it, and you can see it is gray. That is due to our printing process. We have a black fusing agent and a white powder, and so the combination of those two colors is going to give you a gray surface. And here on the right, you have a close-up of a dyed part. And as you can see, you have a much more uniform color, and you have a much richer, darker black tone to it. It really does do a lot to kind of transform the color of the part and really enhance its look. So let's take a look at how this process is actually done. So here we have a smaller setup for dyeing. As you can see, this setup could cost anywhere around $500. Anyone can do this. You could do it in your garage if you wanted to. And it's almost like making French fries in this case. So you have a big pot that you put your dye in your dyeing solution. It can take about 30 minutes sometimes to get this heated up to about 100 degrees Celsius or boiling. And then what you're going to do is you're going to place your parts in that pot with that hot dye solution. The actual dyeing process only takes about 8 or so minutes. You're going to want to stir it occasionally to make sure you have a nice complete coverage. The nice thing about dyeing is it's not just line of sight. It does go into all the little nooks and crannies of the part. So if you have some complex geometries like lattices or something like that, perforations, this is going to penetrate all of that and reach those surfaces. After the dyeing step, you have a post-bathing at a slightly lower temperature than the dyeing phase. And that's going to basically slow down your cooling process, and it's going to prevent deformities like warpage that can happen from too rapid of cooling, and also some splotchiness and some color uniformity that comes from the dye. There is kind of a pitfall of dyeing, and if you don't get your timing or your parameters right, you could end up with splotchiness. We don't have any pictures or photographs or examples of what that looks like, but know it's something that you look out for in your dyeing process. And at the very end, you have to let it dry, but your process is basically over after that. So this is a really simple thing that anyone can do anywhere in their garage, in their factory, and it's a pretty small, easy setup. Next, we're going to look at what dyeing looks like on a higher level, on more of an industrial scale. So here we have a gear bow dyeing system, and this system is really geared towards production. You're going to have about a 2-hour cycle time. One cycle, one batch is going to fit pretty much all of the parts that could fit in a full bucket from our multi-jet fusion printer. And it's going to include all the steps that we talked about before. You basically load the parts, you press go, and it takes care of it. You take them out, you let them dry, and your process is complete. This is really good if you have higher volumes of parts. You're going to have a lower operating cost. You can reuse your dye mix with this machine 5 to 10 times, depending on what type of dye you're using. And it's going to be great, like I said, for high volume production. So whereas the previous method is a low capital investment of only $500 or so, a system like this is more like $20,000, but if you're producing a lot of parts, then that is going to be justified in your running cost savings. All right, let's move on now to graphite blasting. And this really is going to be the simplest way to achieve color uniformity on your parts. As you can see here, these parts have a slight metallic finish to them. And with graphite blasting, the media that you're using is basically like pencil lead shavings. And so that's the type of surface you're going to get there. So let's look into how this process is done and why it's so easy. So the nice thing about graphite blasting is it's pretty much the same process that Dustin went over with part cleaning. The only difference is that you're going to include graphite media with your abrasive media. And this media is pretty cheap also. And so you can do it through a manual blasting process. You can do it through an automatic blaster. It adds no extra time to your process because you have to clean the parts once they come out of the printer anyways. If you add this graphite media, then it is going to add this graphite finish to it. One thing I do want to note before moving on is that this graphite surface finish will wear off on your hands or onto other things. So typically, if this is going to be a part that's touched a lot and handled a lot, it's usually a good idea to finish it up with some sort of clear coat, something really to seal it all in and make sure you don't have any wear. All right, so that was it for color uniformity, and now we're going to look at some of the more interesting stuff, in my opinion, which is going to be how do we achieve colors other than just that gray part. We're going to look at painting, dyeing again, but with color this time, and also hydrographics, which is really, really cool. Great, so here we have another close-up of a raw part, and we have a transformation to a painted part here. The main considerations when painting is the primer you're going to use, the sanding you're going to do, how many layers, and the thickness, and the end finish of your paint coat, whether it be matte or glossy. So let's take a look now at the process itself, and I'm going to go into some of the considerations when you're painting parts. So a lot of times we do recommend first priming the parts. And the reason we want to prime parts is because, first of all, it makes the sanding process, if you do want a really nice smooth surface, a lot easier afterwards. Trying to sand raw nylon versus trying to sand a nice soft primer surface, the nylon is going to be much tougher to sand and to wear down, and it's going to take a lot more time. So you're going to have an easier time smoothing the parts if you're working with a primed part. Primer does also usually help with surface adhesion of the paint coat itself. I have painted raw MJF parts in the past. It does have pretty good adhesion without a primer right off the bat, but especially if you want to look at lighter colors and whatnot, it's going to be a good idea to have a nice light primer put on before those bright colors, just to make sure you have a nice bright surface that you're using beforehand. And so these first few steps of priming and sanding can be repeated a number of times depending on the level of the surface finish that you're trying to go for. We can achieve surface, very high surface quality finishes, very high gloss, automotive-like finishes with our parts. It just takes more time, takes a little bit more TLC with that manual sanding process. The last final steps are going to be painting, and you can do this with a number of coats. And usually, a lot of times people will put on some sort of varnishing step like a clear coat just to seal everything in. And then obviously you have to let the part dry afterwards. So let's take a look at some of the advantages of painting. One, MJF parts can be painted in all different colors. So you're not going to be limited by paint colors. You no longer have to just think about grays or blacks or whites from our raw parts. Now it can be any color that you want. And it's really easy to do color matching with paint as well, which can be important if you have some assemblies that you're going to be integrating these parts into. We can use water-based and solvent-based paints on our MJF parts. It improves color uniformity and surface roughness. The degree to which it improves surface roughness really depends on the TLC you give it, like I said. And you can also achieve other properties like UV resistance and scratch resistance. So it's really multifaceted. It adds a lot of improvements. Before moving on, one more comment I would like to make is the type of finish that you have in terms of paint. So if you're going to spend a lot of time doing a lot of sanding and smoothing before you coat, then you can move into some of the glossier paint finishes and it will look really nice. But if you're not going to spend as much time priming and sanding, then it might be a better idea to stick with a matte or satin finish, which is really going to do a better job hiding that underlying surface texture. When you use a glossy coat on something that has some underlying texture, it's really going to elevate that texture and it's really going to highlight any little imperfections that might be present in the surface. So that's definitely something to consider when you're using paint. All right, let's move forward now to dyeing with color. So here you have gray parts and you can see we can actually dye them a nice, dark, rich color with this Dyemansion technology. They're really the leaders in this field right now, leading the effort of dyeing our gray parts these multiple colors. And they actually have a lot more colors that are either available now or will be available soon. And you can see it really does kind of transform those dull gray parts from this nice, rich color. Furthermore, we can actually take white parts from our 500 series platform and we can dye them even lighter shades. So if you're using a lighter base color, then obviously it's going to be easier to achieve some lighter colors. So definitely something to point out as well. Great. So up next is one of my personal favorite post-processing technologies, and that's going to be hydrographics. And so this is a part that was actually done by Empire Group, and it is one of, I think, the best parts I've seen so far with this technology. As you can see, a lot of TLC, like I was mentioning before, was put into this part before it actually got dipped. You can see they achieved a very nice smooth surface, almost a mirror-like smooth finish with some primer and some sanding. And then they applied this hydrographic film, as you can see all the way on the right, and they also painted the backside. And then to top it all off, they had a nice high gloss clear coat or varnish that they put over it. And like I said, if you achieve a smooth enough surface beforehand, you can have this nice high gloss, very high quality finish afterwards. Moving forward here, we see some examples of some other types of hydrographic films. And what I really want to hone in on here is that so many different finishes are possible. You're really unlimited in terms of the types of films you can apply to parts. Say you want to put your logo all over it. Say you have a customer that really particularly likes a certain sports team. You can get those logos, you can dip it in that, and it looks tremendous. So here we have this really cool camo looking texture that we put on there. You can also use wood grains like you would see in some sort of automotive applications. You're really unlimited in terms of the personalization and the customizability. Great. So this is kind of an industrial setup and how the process is done at scale. But something to note is that it can be done on lower scales, lower volume production as well. But let's go through this higher volume production first. So like painting, you're going to begin with a priming stage, and you're going to have to let that primer dry. And then what you have in this particular setup is an automatic machine which deposits the film, a very thin film, on top of the surface of this big water tank. After that, you have an activator which goes past and is sprayed on top of this film. And that is what prepares it for this ink transfer stage. And in that stage, you can see all these parts are fixtured to be inserted at the same exact angle on all of the parts. And they get slowly dipped into this vat and then pulled up. And so that whole process after the film is deposited only takes about 2 minutes. It's relatively quick. More time is going to be spent maybe fixturing the parts and making sure they're all primed. The actual ink transfer is pretty quick. And at the end, a lot of times people finish it up again with a clear coat just to seal everything in. And yeah, it's not too complicated of a process. It does, if you're doing it by hand, a lot of people hydro dip by hand. It does require some skill and some practice in order to get no distortions. And it can be done, you know, again, in your garage. I've seen film that you can buy on Amazon, hydrographic film, for really cheap. And you can do this, you know, on a case-by-case level if you wish to. So let's talk about some of the advantages of hydrographics. One, you have endless possibilities for designs and patterns. So if you combine the customizability of this film with the customizability of 3D printing, I think you kind of have a triple threat, maybe not triple, double threat. You have, you know, a very high degree of customizability with these two processes combined. It's very, very scalable. You can do it manually, and you can have a semi-autonomous process as well if you're looking at higher volume production. It can be used in combination with other processes like painting to achieve a Class A finish. And lastly, it has a great ability to mask printing flaws. So one thing I've seen is when you're painting something one uniform color, it's still possible sometimes to pick up on defects if they're present. But if you have this 2D image that is applied over a part, it kind of scatters your attention a little bit more, and it just has an extra level of distraction from any type of flaws that might be on the underlying surface. Great. So let's move forward now to surface quality. So we talked about some tips to color parts, but now we're going to talk about how do we, you know, improve the overall feel of the parts? What can we do to maybe take this already pretty small roughness value and lower it even further and improve the feel of the parts? Great. So here again, we have this close-up of a raw part. And if we look here, we have the part after it's been tumbled. And it's really, really hard to show in a picture what the tumbling process has done to this part. As you can see, the color doesn't change a whole lot. But if you were to pick this part up in your hand and feel it, it is very much so noticeably smoother. And we'll take a look at how this process is done next. Great. So this is a setup for vibratory finishing. It is one type of tumbling, but there are a lot of different types out there. There's centrifugal tumbling, there is rotary tumbling, there's a wide number of ranges of equipment in terms of capacity and cost. You really can pick a solution that perfectly suits your application. So even though these technologies are different, they all basically operate the same way. It's the same mechanics behind them. It's all going to begin with this abrasive media, or these abrasive stones that you put in this vat. Every now and then you will have to replace this media or rinse it out because some residue can build up. You place your parts in the chamber or the barrel with this media, and then you begin the vibratory finishing. In this case, you begin that process. And so this is where a majority of the time is going to be spent, but there's no manual labor involved. So anywhere between 3 and 24 hours, this process can go on. Obviously, the longer it goes on, the more the part is going to be smooth. And the mechanics of this is you're setting the parts and this media in motion on top of each other. And over time, this media slowly kind of wears down the surface of that part. If high dimensional accuracy is something you're going after, you can dial and tweak things so that you're not losing too much of the volume or that surface. But know that this is kind of a subtractive process, and it will overall remove some of that surface, especially the longer you go. So then you remove the parts. A lot of times you have to dry them. You can do tumbling wet and dry. When you do it dry, it's a little bit more aggressive. A lot of times people will do a wet tumbling though, because it acts as kind of a lubricant, as a coolant for that abrasive media, which can heat up over time. And you have 3 main variables to control how much smoothing goes on. You have time. So obviously the longer you have them put in this system, the more smooth it's going to be. You have intensity, which is the energy you're putting into the system. For vibratory tumbling, you can control the frequency and the amplitude. And you have the type of abrasive. So you see in this example, there's some ceramic media being used, but I've seen walnuts and other types of really soft media used to do some final polishing, especially in metal applications. So some advantages of this process is it's pretty automatic. If you have high volumes, it's not going to make sense to sand everything by hand. You might start looking into something like this because you have very little operator time. Great. Now we're going to look at something that isn't necessarily a post-process, but it does do a great deal to improve the surface quality of a part. And so here we have a video that we're going to start playing, and it kind of walks through the process of how this is done. So to apply a 3D texture, you begin by marking the seams, and it's almost like you're going to go around with scissors and cut along those seams and unfold that surface onto a flat plane. We're going to see what that looks like here. So you can see we marked those seams, and now we have it unfolded flat onto this plane here. And from there, what you can do is you can take a 2D image, you can put it underneath that surface that you clipped off, and basically it maps that image to that surface. So we have to wait here a couple seconds to see. You can see on one side we have just gray where we don't want this 2D image applied, and on the other side we have that 2D image which will map to that surface that we just cut out. This is called UV mapping. So in just 2 seconds here, you're going to see what that looks like applied to the part. And as you can see, the texture is applied to the surface we want it applied to, and that gray is going to be applied to the other parts. And this is really cool. It's a free software that you can do this in. It's called Blender. And you know, it really does give you a lot of opportunity to add some really cool color images here if you're using our color machine. Next is going to be our 3D texture, and how that's done is with a height map. And so similarly, you map it with a UV space like we did with the color, but you use a black and white height map. And the way it works is it tells the surface of the part to either raise out from where it is or to press into the surface based on the black and white values of that height map. So for instance, a pure black value will get depressed into the surface of the part by a certain amount, and a pure white value will raise that surface out of the part by a certain amount. Here you can see what that looks like applied. And so with this program, you can adjust the strength of that texture, basically the amplitude of how much the white value is going to be set out of the part, how much the black is going to be put in. You can also adjust that mid-level, say if you want your black point to stay steady and you only want the white values to move. So you have some flexibility there. You can see with this one software, you can apply both 3D and 2D textures to parts. You can see we have a lot of examples here of those applied, and we were actually able to print some of them. And one thing you see on these images, we call it framing, which is basically setting the part up so that you're not going to have any noticeable seams. And that's done in another free software called Mesh Mixer. But we're going to go into seams and what they look like and how to address that just a little bit later. So here's an example of texturing used and why it might be useful. So here we tried to print a skin tone part from our 580 machine. And with additive manufacturing and color, one challenge is getting a nice uniform color over a large surface like the one shown here. And so you can see it's not quite as uniform as we'd want. And so texturing, like in the automotive space and a lot of different industries, textures are applied to surfaces, especially big, wide surfaces. If you think of your dashboard in your car, like a leather texture, is often applied to help hide little imperfections, whether it be color, whether it be an actual underlying texture. So that's what's done here. And you can see we have a much more uniform looking part, and those shadows that's created by this 3D texture just help to do that. Great. Here we have another example of a texture applied to a skin tone part. And you can see the color uniformity looks pretty great. And we're able to really closely with our technology match some skin tone colors. But what you will see here is what I was talking about a little bit before, and that's some noticeable seams. So, like I was saying before, the best way, especially if you want some sort of visually, pleasing, very aesthetic part, maybe one that pops out more than this skin tone example here, is you want to frame it such that these seams are going to be hidden. Like I said, that can be done with another free software called Mesh Mixer. You can see the seams here. If you pick the right texture, they are very subtle and sometimes not very noticeable. So you're going to have to pick the right texture for your application and make a decision of whether or not this is going to be something that impacts the final look and feel of the part enough in your application. Great. So here's not necessarily a textured part, but it's something that we discovered in our process here of generating parts for this webinar that we thought was very interesting to share. So I think an O&P, if you're looking at skin tone, I think something that I've seen a lot is with the traditional manufacturing methods, you either have like a fabric that's maybe put over the part to help dull it, or you have a high gloss, very plastic looking part that's really shiny. And in both cases, it doesn't really mimic skin. It doesn't really look like skin. But the unique thing about our technology and what we found here is you start out with kind of this, a little bit of an underlying gritty texture to our color parts here. And with a shot peening process, you can actually mute that roughness just a little bit, not to the point where it has a glossiness to it, but just enough where it feels a lot smoother, and it actually does do a pretty good job mimicking skin. And so that's what we've done here, and we thought that was very interesting to share. Great, so now we're going to look at another really cool technology, and that's going to be chemical polishing. So here we have a raw part on the left, and we have it after it has been chemically polished. So you can see it gives it naturally just a nice darker tone to it because it takes that white powder that's kind of fused to the outside of the part. It puts it into a melt, and that is what gets it to be darker. It also makes it a little shinier, and it improves the surface roughness as well. Let's take a look at how this is really done. So here we have the Post Pro 3D, which is a machine made by Additive Manufacturing Technologies, AMT. And what's unique about it is it's all kind of this closed loop system that smooths the surface of parts using chemicals. So you can see the chemical vapor is introduced to this chamber. It gets circulated around, which means it does reach into all the nooks and crannies of the part, which can be important for certain geometries. And then it extracts it from that chamber as well. So you don't have any messy cleanup afterwards. And basically the manual labor involved with this is just going to be hanging these parts on racks. That's really the only step involved. And so it's compatible with a lot of different materials. Almost every material, or most materials in our platform, I think are compatible with this system. You don't have wastewater effluent. Chemicals are handled in a closed loop zero waste system. They're not flammable or explosive, and they've made sure that they've gotten the important certifications to prove that it's all safe. So in this example, we're looking at fitting these kind of smaller parts in. You can fit roughly 36. It's close to, again, being the size of fitting a full MJF bucket in there. You might have to get clever with how you clip it to these racks. They do have to be hanging, but the process time is only about 2 hours. So relatively quick, not a lot of labor involved, and it really does transform the surface, especially for some of the parts we're going to look at. Next, the overall capacity of it keeps up with about 2 to 3 MJF printers running at full capacity. So that's kind of the speed of it. So here is a look at what it does in terms of surface roughness. So we have on the left here a graph showing an RA value, which is an arithmetic mean that's calculated by taking a stylus that goes over the surface of a part. And it measures all the little peaks and valleys that it experiences. And so a surface roughness RA value of 6.08 is what we get with our raw MJF parts. And that's already pretty smooth. But you can see through this process, it's lowered to 1.5 microns, which is a really smooth finish. It's maybe not quite down to a mirror-like finish, which is sometimes around the 1 and sub 1 micron level, but it does do a great deal. And you can see in this close-up image on the right, what it does to that surface of the part. It takes this semi-fused powder that's on the surface of the part, and it really does put it into a melt and gets it kind of to glaze over and become much smoother. And so chemical polishing really here, what we're trying to show is it does do a lot to reduce surface roughness, and it makes the surface a little bit more uniform. But for some of the other materials and types of parts we're going to look at here shortly, it's going to do even more than that. So let's take a look. So here is this technology used with some of our elastomeric parts. You can see on the left here, we have some that have been dyed as well, some that have not been dyed. And we also have one that has been coated with a flexible coating. And that's something that maybe we didn't really cover. That would have been more in the painting section. I think it's more analogous with that post-process. But it's something that is available for our elastomeric parts. And what's really interesting about this process with our elastomers, it has been shown to improve some of the elongation properties, and it really does kind of plasticize that surface and really transform the feel of the part. So next we're going to see it on an O&P application. So here we have a sleeve that we printed, and we actually made it in Mesh Mixer as well, again, free software. And you can see the difference right after bead blatticing. It kind of has this underlying slight gritty texture to it just because it's a powder-based technology. And when you put it through the process, it really smooths it out. It really makes it look like a finished part here. So you can see just the differences that it makes, especially with these elastomers. Great, and now let's take a look at what it does to color parts. So it's really hard to point out in this picture alone, but you can see it really does help allow colors to pop. It improves the glossiness of them. And I think it's gonna be a little bit more apparent on our actual O&P parts we tried it out on. So let's move ahead and look at those. So here we have some of the textured parts that we printed, and we decided to put them through this AMT process to smooth them. And there's a couple things that I want to point out. One, take a look at the color, especially of those parts on the left. Look at how much it was able to allow that underlying orange and gray to really pop. It really transforms it and it makes it a lot more saturated. But also this 3D texture that is on the right, you can see it's very subtle in that first image. And it's a lot more apparent after this smoothing process. So let's take a look at the close-ups. You can see it a little bit easier, but it really does do a lot to elevate the overall surface quality of these parts. It does a lot for colors and it does a lot for textures. So very interesting to think about when really elevating parts to the next level. Great, and so here is a similar part. It's all the same geometry, but we did different things to it. And the whole point is to show what is possible just with a little bit of some ingenuity and some creativity. So after bead blasting, you have it all the way on the left. That's just straight out of the printer. We have it plus some texture, and then we have the part that's been textured and also has the vapor polishing process done. And really what I want to point out here, and it's kind of hard to see in this image, but it really does transform the surface of that part with the chemical smoothing and the texture, and really does transform it from just a prototype looking part to this very nice finished part that you could see actually being worn. And we'll take a look a little bit at the close-ups so we can see what it does to the surface. And as you can see, the level of detail that we can get with our printing technology is pretty unique. There's not a lot of other technologies out there that can get this level of detail. And you couple that texture that we have with this smoothing process of the AMT, it really does produce a unique, very rich, uniform, high quality surface that you just couldn't get otherwise. And so that's it for AMT. And we're kind of going to wrap this section of the webinar up here. And the main point that I want everyone to take away is that with just a little bit of ingenuity, with a little bit of some creative designing and software that is free too, and some post-processing, you have so many different options of the finish and the types of parts that you can produce with 3D printing with MJF. Me personally, I've been working with these software tools only for a couple of months. I've been working with them, with regard to O&P only a few weeks, and this is what we were already able to come up with. So you can imagine as, technology progresses, as you're able to get your hands on these tools and play around with them, what might be possible in the future. This really is just the tip of the iceberg, and I think there's a lot more coming for MJF post-processing and O&P. So with that, I'm going to hand it off to Dustin now, who's going to cover a few more points here and then take it into the Q&A session.
Thanks, Wesley. Nice work. Wonderful. So as we jump forward, one of the questions that comes up also is, how do you know if you have a good part? And what is a good part when you're doing 3D printing, or specifically with multi-jet fusion? Well, for this particular process and this particular application, a lot of times looking at parts to determine if it's good or bad is usually a primary visual inspection. Now, some people might want to go the next level with that and get more sophisticated, or maybe for a particular application, you want to get more sophisticated. And you might want to know, okay, how do I approach this? Are there different processes out there that I can follow or model or use as a template? And yes, there are. So the FDA has actually put out some guidance. Specifically, their document is called Technical Considerations for Additively Manufactured Medical Devices. And this is something that they're using. They're using what's called leapfrog guidance from the industry that they normally work in to further guide medical specific applications on how to set up quality control systems. So if that's something you're interested in, feel free to reach out to us. We do have this saved, or you could obviously Google search it. Or if you did want to talk with someone about it, we did list their 1-800 number on the bottom, along with their email if you wanted to talk with them and get more sophisticated. Some things to remember, because not everyone is super familiar with all these processes, but after talking to a couple FDA regulators, they've always told me there is no such thing as an FDA approved material, but because raw materials are characterized, whereas medical devices are regulated. So if that's something you're interested in and you want to talk further about, it can get very sophisticated and very detailed pretty quickly, but feel free to reach out to us and we can talk further about that. Great. So one last thing here, before we click on this video, sometimes people ask, what can you do to manipulate these parts? Maybe you need to make adjustments after you've printed to get it to work for the user. Now, what I'll say is there are many ways to do this and many different types of equipment. I reached out to SureStep and they were kind enough to provide this video of how they're doing it today and one option. So this is only one option, but let's go ahead and click the video and see what they have to say about this.
So when we start, we're going to want to make sure we peel away any Velcro and get rid of any glue that's left on there. Let it fully dry before you heat it up. And then to heat it up, it's a lot like regular Polypro, but it is going to lose its color really fast and turn black. Once you get a little bit of shine on it, it flares a lot like a regular Polypro. Pretty minimal pressure. You will lose your color and it won't come back, so you will lose the consistency of the gray, but that's just something we lose when we have to flare it.
So obviously using a torch in this particular scenario, it will change the color of the part. If you were to actually cut our parts open on the interior, they are black. So that's really what you're actually looking into, is to the interior of the part. So that's only one method. There are other methods that you can do, but the important thing here is to point out that you can manipulate parts post-build. Wonderful. So now we're going to go ahead and continue to move forward. And we're just going to look lastly at some design considerations before we get into the Q&A here. So if we move forward here, there are many, many different abilities to manipulate our materials and use them after you've done your print. But if you work with some design considerations, there's a lot that you can do beyond just 3D printing parts itself. So we'll go ahead and get this next slide queued up here. And we're going to look specifically at part joining, so gluing, welding, drilling, and tapping. And if we just double click that section, this is a 3D printed bumper to scale that we actually did print and finish in many different ways with one of our teams. And if we move forward with that, what we wound up doing is printing these in sections, because obviously we can't fully 3D print a bumper in one go with the size of our printers. But as you print it in different sections, we wound up attaching them via different mechanisms just to simply show people what is possible. Now, I'm not going to be going through all of these different attachment methods because frankly, it's pretty dry in engineering, and we do have some design guides on that. But the important thing here is there are a lot of options of what you could do, from heat staking to using hot staples to doing, spin welding. And we do have some design guides on how to actually do that. And they do range in equipment costs. You don't need things super sophisticated. In fact, sometimes having the smaller equipment works better because it's just more mobile and will help you to move around your facility if you need it. So if we move forward, the last thing that I'd like to highlight is some enhanced functionality. So integrating auxiliary hardware, for example. Again, there are a lot of things that we've looked into already if it comes to inserts, or maybe if you want to do a 3D printed thread, what's the smallest thread that you can actually print and use, or doing snap fits. We've done quite a few studies and tests on that to further guide you. And we do have some design guides that we have created. So if this is something that you're interested in or you want to learn more about for designing, again, reach out to us and we're happy to provide those for you. So one last thing that I wanted to mention that sometimes comes up is, hey, what materials should I even consider for a particular application? And with those applications, what can I do to manipulate those materials or those prints after a build? So we just created this high-level chart on what you can possibly do with some of our different materials. Now, if it has a check mark there, it's simply to show that we know it definitely works for that particular process. So for example, under flexible coatings on the right, we're not going to have flexible coatings with something like a PA11 or a PA12 material because it's not a flexible material per se. Or for example, with PA12 glass bead, we don't have a check there for hydrographics because at least for the people who are presenting today, we're not 100% sure that you can do that. We're reasonably confident that you can do that, but since we don't have 100% confidence, we're not going to put a check mark there. But the point here is to show that, regardless of what material you pick, there's a lot of different possibilities of what you can do to manipulate that material. One of our newer materials, polypropylene, we haven't tested it in all different ways yet. So that's one of the reasons why you don't see a lot of check marks there as of yet, because it's still a relatively new material that we launched. Wonderful. So moving forward, we're going to jump into the Q&A section. But before we do that, I just wanted to highlight that we do have a number of resources. So if you want to get some design guides, or if you're curious about air blasters or bead blasters, or some of the dyeing processes like Wesley was talking about earlier, we do have some guides that walk you through that in more detail. We have a number of them. So if there's something in particular that you're interested in, feel free to reach out to us and have that discussion. On top of that, we do have a handbook where you can simply Google search MJF handbook and download specific information about these different processes. So feel free to either Google search that or look up that link that we have hyperlinked there. Wonderful. So now we're going to go ahead and jump into the Q&A. So we have Jason and Carl on board here. So in your interest, Jason, why don't you go ahead and introduce yourself? Tell us a little bit about your background, what your company does, how many years you've been in the industry, and what kind of experience you have with finishing and finishing processes.
Sure, sounds good. Again, my name is Jason Enos. I'm the CEO of Empire. Empire, we are a provider of all services that revolve around low volume advanced manufacturing. We basically leverage all of today's cutting edge technologies. This is something that I've been fortunate enough. Growing up, I grew up in a family of automotive restoration specialists, so I have a ton of experience around finishing multiple materials and multiple parts and things like that. Empire has been around for a little over 20 years now. We've embraced 3D printing since inception, so we've done finishing of basically all different materials and finishes that you can possibly imagine. Currently, HP is probably one of our favorites for a lot of different reasons, but we can dig into that as we go.
Great, thanks, Jason. And Carl, why don't you go ahead and introduce yourself also? And just so you're aware, you might be on mute, but we'll give you a second there.
I was, and now I'm not. I was talking to myself, which wasn't effective.
It's all right.
Thanks, Dustin. So I'm Carl Douglas. I'm founder of DI Labs as well as the president. And at our core, we're a product development firm. That's how we started. That's the experience of all the founders and the principals. We've been leveraging additive manufacturing for over a decade and over 2 decades worth of experience in product development and engineering. And like Jason, we operate several different technologies, and HP is among them. And like Jason, HP is our favorite technology. So that's out of all of our machines, we've got the most number of the same machines of the HPs. And from a finishing technology standpoint, we do dyeing, painting, plating, vibratory finishing, chemical polishing, and a lot of the technologies that were discussed today. And we found it to be effective from one-off, really unique prototypes all the way up to production parts and the runs of tens, 50, 100,000 parts. So a lot of those technologies we use to a certain degree across the entire swath of production volumes.
Great, thank you, Carl. And so in talking with a bunch of orthotics and prosthetics professionals that might not be doing 3D printing today or additive manufacturing, one of the questions that comes up, of course, is if you have to switch your business model or you start to modify it, one thing you want to know, I know having been a business owner myself, is what's something that you wish you would have known before you started into maybe finishing 3D printed parts or acquiring certain pieces of equipment? And since both of you guys have been through that process and been successful, maybe we'll start with you, Jason. Is there anything that you wish you would have known before you got into finishing of 3D printed parts and processes?
Well, if we're talking about just the HP technology, I would say how easy it really is to hydrodip. It's a very easy process that anyone can learn and do relatively easy, and to not be intimidated by it whatsoever. And the other thing is again, this revolves around HP, is really how easy it is to sand a vapor honed type part. I know there was mentioned earlier about how hard it is to sand a raw HP part. Vapor honing really improves upon that. That's probably about the two things that kind of pop out for me.
Okay. And how about you, Carl? Anything that comes to mind for you?
There's been a ton of advancements in the last 18 to 24 months in terms of finishing technologies. But before those were available, we had been in the process of developing a lot of our own. We've developed our own die and vibratory finishing. I kind of wish that some of those technologies that are available today were available several years ago. So I guess the thing that I wish we would have done maybe differently is, well, we can't build a time machine. So it probably would have been to start earlier in the development of some of those processes ourselves, so that we'd be further along today.
Yeah, it makes sense. And just for the attendees, feel free to put things into the Q&A as we kind of continue along here if you have some questions. But on that same token, now that you guys are both finishing experts and you guys do really great works, if it's orthotics and prosthetics or other applications, what do you feel like you can do now that you weren't able to do in the past, given your finishing expertise?
For me, it's really cross-training our staff. It's much easier to finish these HP parts than a lot of the other technologies we've had. So it's actually allowed us to open the door with, for more employment and teach people and our, employees how to finish parts a lot easier, where, some of the other technologies, you can get yourself in trouble if you're not careful. The HP is just such a resilient part that, you got to really put some elbow grease in to disrupt the surface. So it's a lot easier to train someone, I guess, is one of the big things.
Okay. Anything that comes to mind for you, Carl, at all?
I think for us, with the finishing technologies that have been launched and optimized, we're able to deploy, especially the HP technology, we're able to deploy the parts that we produce in the HP technology into applications that were probably unheard of 5 years ago. We've got parts today that are going into the operating room, for example, that are being produced on the HP machines, and they're going all the way through the post-processing. We're finishing them on the AMT Post-Pro, and that enables us to take sealed parts that appear like they're injection molded and take them into the operating room. And that's pretty exciting stuff, especially when you think about the time to market you're able to achieve with that type of printing and finishing.
Big time.
Yeah. Okay. So then another question that comes up quite a lot is costs. Running a business, it's always a dance of, do you invest in this process and this methodology to generate additional business in the future? So maybe you guys can provide a little bit of visibility on how you figure out, if a particular finishing process or method is worth investing in, and maybe how you kind of justify that.
I can speak to that a little bit. Really, a lot of it has to do with scale in the volumes of the stuff you're doing, if it makes sense to become more efficient by some of these new technologies. We are very careful on getting into new technologies and making sure that there's a good ROI on that. So if we have a lot of, I guess just call it work and a lot of need, then it makes perfect sense to get into the, the stuff that adds value and speed around surface finishing.
Okay. How about you, Carl? Because I know you guys at DI Labs, you guys are involved in quite a few different applications that you specialize in.
We are. We're, by nature, we're risk takers. I am, as well as my brothers. We're a family business, and we grew up in an entrepreneurial family. So we're all about taking smart risks, and in a lot of cases, we'll invest in technology before there's a real solid business case for it. And we'll do that because we believe that there's a trend in the marketplace where the type of finishing is going to be in demand. And in some cases, our customers don't even know what they really want because they don't know what's possible. So we see ourselves as the ones who have to forge that path, validate what's possible, optimize it, and then be able to provide that to our customers and help them put themselves in a position of creating differentiating characteristics for their company.
Good point. And one of the questions that we have here, and this might be, I'll say kind of directed towards Jason here, is one of the questions is it possible to achieve static charge powder coating? And I know you do quite a bit of painting and really high surface finish parts over at Empire Group. So is that something that you've ever experimented with at all?
No, and actually I might have just got a little bit of education from Carl on that because, you know, I think, you know, from my past experience, just on the type of parts we're doing that, you know, it wouldn't work because of the heat. I would just deform the part and things like that. But I know Carl had mentioned some UV cure and a little bit different take on that. So I'm actually a little curious to hear what he has to say.
Yeah, how about you, Carl?
Yeah, that's a good question. We've played with that a little bit. It is possible to achieve a static charge. Of course, that requires a coating. The second part of that, which Jason talks about, is the temperatures for powder coating. And doing that with a PA12 or PA11, you're asking for trouble. We've contemplated doing some testing at low temperatures with the glass-filled PA12. And we haven't gotten there yet, but the question kind of sparks some interest for us to maybe take that on and move it up our pipeline.
Sorry, Carl, that was actually Wes that said that.
Yeah, and I just want to step in here and say real quick, I answered this in the chat, but we have actually started working or sending samples to a company that does a UV cure type powder coating, and we've seen some pretty excellent results with that. What's interesting about powder coating is that you can get a really thin film applied. It has some low cost, especially at high volumes. But yeah, with this UV curing versus just raw heat like you would on a metal part, we have seen some great results. So if anyone is interested in that in particular, I'd be happy to make introductions or discuss further.
Nice. Great.
Thanks for jumping in, Wes. So I know we are a little bit over, but let's just take two more questions that we have here in the Q&A, and thanks for the questions, everyone. So one question that Kat has here is, other than vapor smoothing, are there suggestions to better post-process with multicolor parts to smooth and enhance colors? So it's an interesting question. Do you guys have any suggestions for things that you guys have done besides vapor smoothing?
I can step in a little bit here to address this. So, you know, we talked about surface quality enhancements or improving the roughness of the parts. And really the two that we talked about were vapor polishing and tumbling with an abrasive media. So I have tried both. Vapor polishing, I think, overall amplifies and really saturates the colors and makes them look a lot better. I have tried tumbling with colored parts from our 580 machine. And while it doesn't strip away the color necessarily, especially if you do it gentle enough, it doesn't do anything to enhance the color. So I would definitely recommend the route of vapor polishing if possible for color parts. But if you're okay with a little bit more muted colors, then tumbling is something you consider if you are doing this on a smaller scale. Sanding, I haven't done a lot of, but I do know we have a certain thickness to our actual color perimeter that's printed around the part. And so as long as you're not too aggressive on the sanding, then theoretically, you should be able to do just a little bit very gently and still have some color left.
We've used plastic shot. It's often referred to as poly shot, but we've used plastic beads in our bead blasting equipment, and we have found that we're able to achieve some sort of sheen, and it does improve the colors a bit, not to the level that the AMT machine does, but that's another way that we've been successful with the color parts.
Great. Thanks, Carl. Thanks, Wesley. So we have time for one last question here, and this is actually directed towards Carl. Roger asks, when you say it's easier to train your employees, is that partially because of HP's support?
I think that may actually be directed towards Jason. I know Jason made the comment about easier to train. Go ahead, Jason.
Yeah, that's me. Thank you. That meant to kind of speak to the actual materials of HP. And what I meant by that when I was trying to get across on that was, you know, in the old days, you know, it was very easy to sand off a detail or put a radius on a part that shouldn't be there. You know, it's basically to try to capture the design intent. With HP, it's very, very tough to manipulate the part. So you can take an inexperienced person and get them involved with the finishing easy because you don't have to worry about them, you know, wrecking the intent or the look of the part. Is kind of what I meant by that.
Great. Okay, and with that, I realize we are past time, so thank you all for hanging around. As mentioned, if you want to reach out to us, or if you want to reach out to Carl, Jason, feel free to get in touch with us, and we're happy to put you in touch with them. But thank you all for joining today, and we hope you have a great week.
Thank you.